Section 2.3, Example 12. Mary has a set of posters to arrange on her bedroom wall. She can only fit 2 posters side by side. If there are 72 ways to choose and arrange 2 posters, how many posters does she have in total? In this example, we are given the total number of ways to arrange 2 posters. What we're looking for is the number of posters, and that is what we call, or what we're going to label, N. So in this case, we're looking for N. So this we can write as NP2. We're looking for the number of posters and we're arranging 2 posters. And there are 72 total ways to do so. If we use our permutation formula, NPR equals N factorial over N minus R factorial. We have N factorial divided by N minus 2 factorial equals 72. Again, considering which is larger, N is larger than N minus 2, so we're going to start with the larger and rewrite, starting with N times 1 less than N, N minus 1. 1 less than N minus 1 is N minus 2. And then we stop as we see that in our denominator we have N minus 2 factorial. So we can cancel out N minus 2 factorial. And we are left with N times N minus 1 on the left side and 72 on the right. From here, we are going to solve for N. We're going to distribute N times each of N minus 1. N times N is N squared. N times negative 1 is negative 1N equals 72. This is a quadratic equation. To solve a quadratic equation, we want equals 0. So we're going to subtract 72 from both sides. We end up with N squared minus 1N minus 72. From here, we need to factor. So we are looking for 2 numbers that have a sum of negative 1 and a product of negative 72. What plus what will give me negative 1, and what multiplied by what number will give me negative 72. Looking at the factors of 72, we can see that 8 and 9 will give us 72, so one of those numbers need to be negative. Looking at our sum, we need to add together those 2 numbers to give negative 1. So we can see negative 9, or 9 has to be the negative number. 8 and negative 9 works. Placing those back in our factors, that trinomial of n squared minus n minus 72 is factored to 2 binomials, n plus 8, and the other one is n minus 9. Using our zero product property, then the first factor, n plus 2, must be 0, or the second factor, n minus 9, must be 0. Solving for n in each case, subtract 8. We end up with n equals negative 8. And this one, we add 9 to both sides. N is equal to 9. Similar to other examples we've done, we end up with a n value of negative. We cannot have that, so we reject that solution. N has to be a positive natural number. So our solution is n equals 9.